Yeah, hi Arun, good morning.
Good morning.
So yeah, Arun, good to go. We can start with the day one for CCNP security.
Okay, sure. Okay, so hi everyone, good morning. So a little bit of introduction about myself before we start with this. So my name is Arun. I have around 10 years of experience. It mostly has been on Cisco side of things. I've worked on collaboration, worked on IoT, and for some years now, I've been mostly focused on the security side of things. So I have a CCI in collaboration. I have CCNP security, and then um, I'm into automation and DevNet as well, and then some other um, vendor neutral industry-based security certifications, Security Plus, CEH, and those sort of good stuff. Okay. So our focus for this is going to be primarily CCNP security. We are going to be going through a lot of different topics, a lot of different products, a lot of different technologies. Okay. Let me just share my screen. Okay. Hope everyone can see it.
Yes.
Yeah.
Okay. Just and if anyone has any question, just drop it in the chat window. Okay. Let me just put the chat window up. Okay. So I'm monitoring the chat window. If anyone has any questions, just put that up in the window there. Okay, so that everyone can see what the questions and everything are. Okay, so what we are going to start with is the network security part. Okay, that's what our focus is going to be for the initial some classes. Okay, and primarily we're going to be talking about firewalls. Okay. Now, traditionally, when we are talking about something like firewall, it's basically a device that is used to implement access control. Okay, that's really what it's meant to do. Okay, access control from people or for people trying to access, let's say, the internet from within the organization, and also for people who are trying to access maybe the resources that are present inside of your organization. Okay, people who host websites. Okay, maybe some cloud-based services. Okay, so internet-based users or remote users trying to access your organization's resources. Okay, who you allow, who you don't allow, what they're allowed to do, what they're not allowed to do, all of this kind of becomes a part of this access control. Okay, so at a very high level, that's what a firewall is meant to do. Now, there are a lot of different types of firewalls. Okay, and speaking traditionally, we used to deal with just our basic packet filtering. Okay, which sometimes is also known as stateless firewalls. Okay, now these were the first generation of firewalls, first generation of access control devices. Okay, and they were pretty simple to operate, but they had their own administrative and configuration-based issues. Okay, So for example, if we have something like this, okay, a very basic topology here, right? So this user maybe is trying to access something like, let's say, eBay.com. Okay. Now, in order for this firewall to allow this traffic, you would have something like, on this firewall, you have something like a rule defined, which will say something along those lines. Okay. Permit IP any EQ8443. That's basically your HTTPS traffic. Okay. Any return traffic coming in from the outside, okay, you would again have something like this defined. Okay. Any source, and maybe you'll provide a destination. So let's say your LAN users are sitting at RFC 1918 address space. Okay, so you would define something like this. Okay. This is a basic packet filtering. This is a very basic firewall, and it's stateless. Why it's stateless? Because the firewall here does not keep any state information. Okay. Once it allows this outbound packet to go through, that's about it. Okay. He does not keep any knowledge about it. He does not really care whether that packet was delivered or not. Obviously, if it's HTTP, then HTTP and TCP are going to take care and make sure that everything is being sent reliably. Okay. But from the perspective of the firewall itself, it hardly cares. Okay. That's why it's stateless. Okay. Any number of or any amount of traffic that you would want to allow through this firewall, you would need to create additional what we call as these access control entries, ACEs. Okay, so you need to create multiple of these. Okay, so let's say you have 10 different subnets. Okay, for your LAN users, you would need to create 10 of these statements here if you want to be as specific as possible and you're not trying to use the any statement. Okay, then you need to create 10 of those statements just for outbound traffic. And then similarly, when you're sending something outbound, you would have return traffic as well. Okay, so you need to create access control entries or ACEs to accommodate for those return traffic as well. Okay, so the firewall does not really keep a track of what really is happening and whatnot. Okay, so this was the first generation of firewalls, packet filtering, stateless. Okay. After this, we moved into what we still use are your stateless firewalls. Sorry, stateful firewalls. Okay, you can call these second gen firewalls. And the concept of stateful firewalls, and not a lot of people know that, it's from Checkpoint. Okay, so Checkpoint CEO, founder, 𝐍𝐤𝐳𝐬, he was the one who actually invented the concept of statefulness, okay, within firewalls. Okay, and whatever we use, or any single firewall, or every single firewall out there, be it Sophos, be it SonicWall, Checkpoint, Palo Alto, Cisco, Fortinet, you name it, all of these firewalls are stateful. Okay, and Checkpoint is the one who actually invented the whole concept of stateful firewalls. Okay. Now the benefit of stateful firewalls over stateless is your stateful firewalls, they maintain what we call as state table. From Cisco's terminology perspective, Cisco calls it a connection table. Okay, same thing, same concept, a different terminology. Okay. Now what these are, if we look at same scenario, okay, as we had above. Okay, so when this guy here, he tries to send traffic outbound, okay, this firewall is going to create an entry for this connection, okay, within a table, basically. And this table is going to have a bunch of information, okay? So for example, source IP, destination IP, source port, destination port, protocol, okay? If you're using, if it's basically TCP traffic, okay? HTTP, HTTPS, anything else, SSH, okay? All of that. It will also keep a track of the TCP data, okay? Sequence numbers, okay? And other TCP state information, etc. Okay, so it will keep creating these entries here. Okay. Now, how does it help? So on this firewall, you would have kind of like the same rule here to allow this outbound traffic, right? So rule 1 permit. Let's make it a bit more specific. Permit TCP 10.1.1.0.255, any destination, say 443. Okay. But since we are using a stateful table, you don't need to create additional access control entries for return traffic. Okay, just like we had to do with stateless. You don't have to do that in stateful. Anytime you create an entry, this entry becomes bidirectional. Okay, so the traffic will go out and then it will be allowed to come in. And remember, this is return traffic. Okay, this is not the traffic originating from the outside. It's just return traffic. Okay, you send HTTP GET request to eBay.com server, it's going to send 200 OK and some data, etc. That's basically return traffic. Okay. In stateless, you will need to have an additional entry to allow that return traffic as well. In case of stateful firewall, you do not. Okay. So anytime you create an entry, that entry becomes bidirectional and it's able to cater to return traffic as well. Okay. How it's able to do it? It's based on the state table. Okay, so if you talk about a little algorithm which goes into the stateful firewall, so anytime there is a new connection, okay, so let's say there's a new packet that comes into the firewall, there is a check that's done. And the very first check that it's done, it sees, does or is there an existing connection for the traffic? Okay, which what it's doing, it's trying to consult its state table. Okay, if there is an existing connection present, okay, there is no ACL check that's done. Okay, so there's an ACL check bypass. So access control entries are not checked if there is an entry present in the state table. Okay, because of that entry, the firewall is able to relay that, hey, this traffic is just a return traffic coming in for an existing connection. Okay, so I don't really need to do additional access control checks for this. If, however, an existing connection is not present, then there is an ACL check that's done. Okay. If there is a permit rule, okay, we allow and add the entry to the state table. If it's a deny statement, we drop. Okay, so it's as simple as that. Okay, so using a stateful firewall, doing administrative work, doing configuration and everything, it becomes a lot easier. Okay, so in this case, you would have to create 10 entries, like I said, okay, 1 per subnet, and then you'll have to create 10 more entries for incoming traffic or return traffic as well. In this case, you only need to create outbound entries. Okay, you only need to create permit rules for your 10 subnets. Okay, and as long as the state table is maintaining those entries, you don't need to create additional access control entries to allow for return traffic. Okay, and this is how the algorithm kind of works at a high level. Okay, obviously, when we look at let's say Cisco ASA or maybe next generation firewall, there are going to be additional things that go into it, but from a very basic high level perspective, this is how a stateful firewall really operates, or it really works. Okay. These were the second gen. Okay. Like I said, every single firewall nowadays is a stateful firewall. Every single firewall maintains a state table. Okay. Now there are a couple of other types of firewalls as well. One of them is an application layer firewall. Okay. So these two firewalls here, stateless and stateful, they only work, or they can only analyze based upon what we call as 5 tuples. Okay. These 5 tuples are source IP, destination IP, source port, destination port, and protocol. Right? These are the 5 tuples. If you're going to look at here, we have these 5 tuples in here as well. Okay. So these traditional firewalls, stateless and stateful, you can also call them as layer 3, layer 4 firewalls, because that's all that they understand. Okay, they will be able to understand port 80 and port 443, but they won't be able to understand HTTP. Okay, there's a difference between the two. So when I say to you, hey, it's port 80 or 443, you instantly know, okay, this is HTTP. The firewall does not. Okay. For that purpose, you have these application layer firewalls, okay, which work at layer 7. Okay, they can analyze the actual data or the actual payload. Okay, for example, if a firewall needs to know that a traffic is HTTP or HTTPS, all that he needs to see is HTTP GET request. Okay, so as soon as the firewall sees an HTTP GET request, it knows that, hey, this is HTTP traffic. Okay, so application layer firewalls are meant to do that, right? So traditionally, stateful firewalls were there, okay, and then we used to also deploy application layer firewalls, okay, because if I am creating a rule like this, okay, this rule is meant to, or let me just write something else as well. So if I'm creating a rule, let's say deny TCP, okay, or let's just say port 80. This basically means that we will be denying any traffic, okay, any source, any destination IP that is meant for a destination port of 80. Okay. Now, what we are aiming to deny with this or block with this is our HTTP traffic. Okay. But what if someone in my network, okay, is able to send HTTP traffic over port 8080? Will the firewall be able to block the traffic with this rule? No, it won't be able to. Okay, because the firewall or these traditional firewalls, they are not application aware. Okay, again, they only operate layer 3, layer 4. Okay, nothing beyond that. So this thing here, this kind of became an issue, at least nowadays. Okay, when we have a lot of different types of attacks, a lot of different things that's going around from a security landscape perspective. Okay, so, and this is a very common thing that attackers and hackers basically do and use. Okay, they try to use uncommon ports to do data breaches, to do data exfiltration from the network. And if your firewall is only operating at layer 3, layer 4, he is basically blind to if someone might be using other uncommon port for these common protocols. Just like I told you a name, very basic example for HTTP. Okay, so for these purposes, people start to purchase and deploy application layer firewalls as well, because they wanted to have that application awareness. They wanted to see that if I am using, or if a packet is using 80 and 443, it is only meant for HTTP, okay, and nothing else. Okay, so you had stateful firewalls being deployed, and then you had application layer firewalls being deployed together. Okay, another variation or another part to it could be a WAF or a web application firewall. Okay, that is typically meant to protect your applications that are running on the on servers. Okay, this is from the perspective of network-based traffic. Okay, and your WAF is basically perspective of an application. So let's say maybe you're running an Apache server, and maybe you're hosting an application there. Okay, so you might be running a WAF in front of that application, so that any traffic that is going to the application itself, it can be monitored, and it can help protect the application against various application-based attacks. Okay, so you can look at something like OWASP top 10 if you want to check what are the latest threats related to web applications. Okay, so you had application layer firewall, and then you have your web application firewall. Okay. Now, the current generation of firewalls, they basically combine all of these together into a single device. Okay, so traditionally you'll have to purchase 3 different products, okay, or maybe 2 different products to implement layer 3, layer 4 stateful firewall, and then another one to do layer 7. Okay. But now you have the current generation, which we basically call as next generation firewalls. Okay. These firewalls, they are layer 3, layer 4 stateful firewalls. They are application aware as well. Okay, so they can help against web-based attacks, etc. They are user aware as well. Okay, so maybe let's say I want to, so I have different business units, maybe different LOBs in my organization, and let's say the only part of my network or the only users on my network, let's say the sales and the marketing team. Okay, those are the ones I want to give them access to something like social media. Okay, but I don't want to give social media access to maybe the IT team. Okay, so I can have my firewall learn and understand the users as well that are trying to use the network. Okay, so I can make my firewall user aware as well. Okay, so that know that this user needs to be allowed access to this resource. Okay, whereas a different user won't be allowed access to this particular resource. Okay, so there's user awareness as well. In some cases, some firewalls, this might be called as identity as well. Okay, it's one and the same thing. The next generation firewalls help with web content filtering. Okay, they help with URL filtering, right? Which is typically based on categorization and reputation. Okay, we'll discuss this later on in a little bit more detail. Okay, another important thing that next generation firewalls can help you with is SSL or TLS decryption. Okay, very important nowadays. Okay, everything is web-based and everything is secure. Okay, so if you want your firewall to be able to analyze your traffic better, you need to decrypt that traffic. Okay, because if it's encrypted, then your firewalls or any other security devices are basically just blind to the traffic, actually, to the contents of the packet. Okay, so very important perspective. When we talk about these traditional firewalls, you had to implement an additional device, something like an SSL decryptor. Okay, basically at the very edge of your network. Okay, so the traffic first came into the decryptor, it was decrypted, then it was handed over to something like a stateful firewall. It used to analyze the layer 3, layer 4, and then it used to be sent to an application layer firewall, which used to analyze the layer 7 part. Okay. So the next generation firewall, that single device is capable of doing a lot of these things on a single box. Okay. So you have SSL TLS decryption. And then some other important things are protection against malware. Okay, your viruses, Trojans, worms, okay, things like ransomware. Again, part of the malware itself, okay, but various different names to it. Malware protection. Okay, and this typically is both signature based, okay, and solutions also provide sandboxes. Okay, and this is typically helpful for protection against zero-day threats. Okay, You also get antivirus. Some of the devices, they provide anti-spam as well. Okay, and anti-spam is kind of like the email protection side of things. Okay. Right. So these are the typical capabilities of the next generation firewalls. Okay. And as you can see on a single device or a single firewall, you can basically achieve a lot of things. Okay. Sometimes you might also see next generation firewall or some of these devices being called as UTMs as well. Okay. Stands for Unified Threat Management. Kind of like the same thing, right? Unified threat basically means you have a single device that is within its capabilities as a single device can help you manage a lot of different threats and everything. Okay, so it's unified. It's a single box. Okay, so they are typically used interchangeably. Another important aspect that next generation firewall provide is IPS and IDS capabilities. Okay, people who don't know what that is, IPS stands for Intrusion Prevention System. Okay, and IDS is Intrusion Detection System. Okay, a next generation firewall is basically incomplete and is of no use without an IPS. Okay, so when this trend of IPS kind of started in the 90s, end of 90s, starting of 2000, okay, so again, you would have a separate device which was only doing IPS. Okay, so you would have the firewall, you would have the IPS, you would have the application layer firewall. Okay, sort of a lot of these bunch of different devices used to be properly implemented in the network so that the traffic can be sent to each one of these in kind of like a serial processing kind of a way. Okay, to help protect against the various different types of attacks that might, or different types of malicious traffic that might be present or going through or coming in to your network. Okay, but with these next generation firewall and these UTMs, we now have all of these working within a single device. Okay, so the IPS and the IDS part is a very important part for any next generation firewall. Okay, so that is your next generation firewall or your UTM. Okay, these are the current generation of devices. These are the current generation of firewalls. Okay, and most of the vendors out there, okay, I know we'll be talking about mostly from Cisco's perspective, but anyone out there, they're providing these next generation firewall in a bunch of different form factors. Okay, you can buy hardware appliances. If you are in a virtualized environment, okay, and you want to protect your virtual network as well, right? Your ESXi environment, maybe your Hyper-V environment, etc. You can implement these as VMs as well. Okay, and maybe if you're also trying to protect, or if your organization utilizes public cloud, then you can deploy these in public clouds as well. Okay, things like your AWS, GCP, Azure. Okay, so lots of different use cases and everything are available depending upon what you're trying to do. And if you have deployed this on premise, okay, to protect your environment, there's no real difference if you take that firewall and implement it in the public cloud. Okay, so you still have these same features and everything that you are now going to be using to protect your public cloud environment. Okay, right? So those are various different types of firewalls that we have. Okay, so initially we'll be focusing on the layer 3, layer 4 side of things. We will just try to understand how stateful nature actually works. Okay, there are various things that go into it. All right. And then after that, we'll be looking at the next generation firewall side of things. Okay. So from Cisco's perspective, if we look at all of these, so your stateful firewall, this is where you have your ASA. Which is short for Adaptive Security Appliance. Okay. From next generation firewall perspective, Cisco has your FTD, okay, which used to be called as Firepower Threat Defense, but nowadays it's basically called as Secure Firewall Threat Defense. Okay, I'll go over the name changes as we proceed to the other products and the firepower in detail. Okay. Before I move forward, any questions with respect to any of the firewall types, any of the capabilities or anything? Okay. So let me just bring up the topic of ASA, okay, before we kind of end the class for today. Okay, just a very brief introduction to ASA. Okay. So ASA is Cisco's one of Cisco's oldest products, okay, and it has been in their portfolio for a very long time. Okay. They evolved. So Cisco used to have, if someone is old enough, they used to have a stateless firewall, a packet filtering solution, or kind of like a stateful kind of nature-based firewall. They used to have what they used to call as PICS, okay, which used to stand for Packet Internet Exchange. Okay. Cisco then acquired an organization by the name of Altiga Networks, through which they got a VPN concentrator product. Okay, because this PICS firewall was not capable of doing remote access VPN, etc. Okay, it still could do site to site, right? But it could not do remote access. Okay, and it was very important. So they started selling PICS and then the VPN concentrator. Okay, moving forward to, I believe, somewhere around 2004, 2005, this kind of evolved into ASA. Okay, whereas there was this singular unified product which used to offer the capabilities of both PICS and VPN concentrator. Okay, so your ASA could now do basically site-to-site VPN, remote access VPN. Okay, you could do client-based, clientless, right? And then it used to do all of the good layer 3, layer 4 based stuff as well, stateful firewall. Okay, so that's how the ASA came into picture. Okay, and once this kind of became successful, okay, because again, we were moving from having to deploy 2 products to just 1. Okay, and ASA like I said, it has been a very successful product, or one of the very successful products for Cisco. Okay, since 2004, 2005, it's still being implemented. It's still available. There is no end of life for ASA as of yet. Okay, so it is one of their longest running solutions. Okay, and it's pretty good. It's pretty versatile. Okay, so that's how the ASA came into existence. And like I said, ASA is your layer 3, layer 4 stateful firewall. Okay, it can do some additional things as well. For example, it can do layer 7 as well. Things like URL filtering. Okay, but it's kind of like a very, I wouldn't say a very niche feature, but it is a capability that it can do. If a customer has an existing ASA deployment and they want to take care and they want to make use of the layer 7 capabilities, okay, they can use URL filtering for ASA. But if you're maybe kind of like trying to do a newer deployment nowadays, and you want to have a firewall or a security appliance that can help you protect against all of these attacks, you want them to be layer 7 aware, then ASA is something that you will not deploy. Okay, so layer 7 is something that you do not use ASA for. Okay, so if you already have an existing deployment, a customer already has an ASA's existing deployment, they can utilize that, right? But for newer deployments, you typically would be going with something like a next generation firewall. Okay, and your ASA can do basically everything related to routing as well. Okay, so depending upon how you deploy it or how you implement it, you can do routing as well. Okay, if you implement it at the edge of your network, right, you would typically want to do or want to run eBGP with your service provider. Okay, and then have any other IGP running on the inside. Okay, if, however, you try to implement it, let's say at the data center edge, maybe. Okay, if you want to protect your both your north, south, and east, west traffic. Okay, one use case for implementing it in the data center at the data center edge. Okay, that's where you can have it run IGPs on both sides. Okay, so it is basically a full-fledged router. Okay, so it's router plus security. All right, and you can also run it as just a pure layer 2 switch as well. Okay, so we'll discuss this. I'll show you how the implementation goes for the layer 2 switch part, why, where you would typically want to use that. Okay, but this is a more common deployment. Okay, have the firewall act as a router and then implement security features on top of it. Okay. Now, when you are first implementing something like ASA, okay, you would obviously be bootstrapping a new device. Okay, so let's say we purchased a new ASA. Okay, and we want to implement it, our internet edge. We have our LAN network here. Okay, so this is, let's say, 𝐍𝐞𝐭𝐰𝐵/0 interface. This is 0/1. Okay, and we have our internal network at a 10.1.1.0. Okay, this is how typically I want to have Firewall. Okay, two interfaces, one connecting to the outside, one connecting to the inside. Okay, this type of deployment, this will be called as dual homed. Okay, so it'll be a dual homed deployment. If I have or if I want to implement a DMZ network as well, okay, maybe I use another interface on here and run off of my DMZ. Maybe I am an e-commerce organization, right? And I host my own Apache servers, other web servers, etc. Okay, maybe my mail servers as well. Okay, can implement DMZ. Okay, in this scenario, this deployment will be called as triple homed. Okay, so very basic terminology, dual homed, two interfaces. This is going to be a more common deployment. Okay, and this is kind of reserved for people who really want to utilize DMZ as well. Okay, so now if you have an ASA, okay, and let's say we are going for a triple home kind of a deployment, okay, the very first thing obviously is for you to bootstrap a new ASA device. Okay, so I'll show you the bootstrapping and then I'll go into the details about how it's actually working or how the firewall actually takes care of the traffic. Okay, so let's suppose we are, let's say configuring this interface here, 𝐊𝐢𝐧𝐠𝐬/1. Okay, so there are 4 important interface commands on a new device or when trying to bootstrap a new device. Okay, so for this interface 𝐊𝐢𝐧𝐠𝐬/1, right? The very first thing is obviously you're going to put an IP address. Okay, and let's say I give it a 10.1.1.254. Okay. Now the ASA, it will look very similar if you have worked with Cisco iOS routers or switches. Okay, CAD iOS, CAD OS, and then specifically the router iOS. Okay, CL and everything, it will look very similar. Okay, but there are some substantial differences, and I'll go over those whenever I feel like. Okay, one thing is it's not necessary for you to give a subnet mask. Okay, on a router you will have to give a subnet mask as well. But here, if I just put in an IP address and then my IP address and I can hit enter here, okay, it will add a subnet mask on its own. And the subnet mask will be for the classful boundary. Okay, so for example, this is a class A IP address. The default mask that it will put in, if I do not specify a mask, is a /8. Okay, which is the classful boundary for class A. Okay, so if that's sort of an IP address that you have, then sure, you don't need to give a subnet mask. But for example, like in my case, I have mentioned a /24. Okay, then I would need to put in a subnet mask. Okay. The next important thing on the ASA is giving a name to your interface. Okay? So on the ASA, everything, or I should say the interface, are referenced by the name. They are not referenced by the interface number. Remember this. Okay, so make sure, depending upon what interface and what part of the network that interface is going to be catering to, okay, you give some proper names to the interfaces. Okay, interface names which are much more intuitive. Okay, so you can look at the configuration and you can see, okay, this interface, this caters to my LAN, or this caters to my DMZ or something like that. Okay, you give the name to an interface with the nameif command. Okay, and for example, this is going to be facing my LAN here, so I can give it something like nameif inside. From this point on, anytime I have to reference this interface, I would use the name inside. Anytime I create policies, maybe I create my NAT statements and everything, okay, I cannot use interface numbers. Okay, when you look at the routing table and everything, you won't find interface numbers. Everything will be referenced through interface names. Okay, and the name is something that you give right under the interface. Okay, it's very important. Another important thing, and this is how the ASA actually implements security, okay, is through security level. Okay, security level ranges from 0 to 100. Okay, and you can give any number that you want. From ASA perspective, there are two defaults for security level. Okay, and those defaults work against particular names that you can provide. Okay, so for example, if on an interface you give the name or you name an interface as inside, that interface will get a default security level of 100. This is within the ASA code. Okay, no way for you to change it. If an interface is given the name of inside, security level will be configured automatically, and that will default to 100. You can change this value, but you cannot change the interface name. Okay, so you cannot configure, let's say I want to configure default 100 for something like a LAN named interface. You cannot do that. Okay, it's only for an interface that has been given a name of inside that will default to 0. For everything else, or any other name, the security level defaults to 0. Okay, so for example, if here, or maybe on another interface, for example, let's say when we configure the 𝐍𝐞𝐭𝐰𝐲 as 0 interface, we configure the name if as outside, it will default to security level of 0. You can change that security level. Okay, but those are the default values. Okay, so name if inside, if any interface is given the inside name, that interface by default gets a security level of 100. Every other name will be defaulted to 0. These security levels can be changed. The defaults cannot be, but you can manually come in and you can change. Okay, the concept of security level is very important, and we'll go over it most probably tomorrow. Okay. The last thing is obviously just like a router, you have to unshut the interface. Okay. So these are the 4 important commands that you need basically on an interface when you're trying to do a bootstrap of a new device. Okay. Similarly, you would configure the other one as well. Outside or WAN facing. Okay. So give any IP address. Let's say we'll do 100.111. Okay. And I'll call it name if outside. You can call it name if WAN, name if ISP, whatever it needs to be. Okay. It defaults to 0. Any other name and it default to 0 can be changed. And then no shut. Okay. Now a couple of things additionally are required, right? One is maybe set up a routing, okay, or maybe give it a default route, default static route. Okay. So you can do something like route, and you then provide the interface, the exit interface. Okay, so the exit interface is 𝐍𝐞𝐭𝐰𝐵/0. For any default traffic, you want to send it obviously to the internet. Okay, but again, you cannot use interface numbers. Okay, you have to write the name. So 0/0 is being referred to as outside. So you give route outside. You configure your default route. Okay, again, something very different from a router. Okay, so on a router, this would need to be configured as 0/0/0/0/0, right? On the ASA, you don't need to do it. Okay, you can just do a 0/0, which will be expanded by the ASA on its own to these values, but you don't have to really configure those. Okay, and then you configure basically the next hop. Okay, so let's say there's the provider edge here. That's a default route. Okay, a default static route. Okay, so a route, the exit interface, okay, the actual route basically, and then your next hop IP. And then obviously you'll have to configure your NAT and everything as well. Okay, not going to NAT. NAT is a pretty big topic for ASA. We'll cover it on its own later on. Okay, so with this configuration that you have in place, and when you put in your NAT statement, this user will be able to access the internet. And we have not configured anything else. Okay, we have not configured any other policy, any other access control entries, access control lists, access control policies, or anything. Okay, this is the minimum configuration that is required or that will be used here to allow inbound to outbound traffic. Okay, so this will be allowed. And any outbound inbound traffic will be blocked. And when I'm saying it's allowed, it also applies to return traffic. It's a stateful firewall. Okay, so this guy trying to access maybe a website or anything, that will create a state entry. Okay, and then when the return traffic comes back in, the ASA is going to check for an existing connection. If it's present, it will bypass the access check. Okay, so with this configuration in place, you can achieve inbound to outbound traffic. Okay, and you can also not allow any unauthorized outbound to inbound traffic into your network. Okay, this is the very minimum bootstrapping of a new ASA device that you need. Okay, and we're talking about two interfaces. Obviously, I can put in the DMZ as well. Okay, this is just typical dual home. Okay, any questions?
No.
Okay. Okay, so I think that will be it for today. Okay, we'll continue with this tomorrow. Okay, so we'll have 1 hour classes today and tomorrow, and then from next week we'll have extended classes. Okay, so we'll end this here today. Tomorrow we'll look at how this default behavior is being accomplished, okay, and why you really don't need any access control entries or lists or policies to actually achieve the default traffic. Okay, so, and I'll go over the security level concept as well tomorrow. We'll look at some of the more deployment ways in which how you deploy these interfaces versus how do you deploy the appliances. Okay, so tomorrow we're going to do a lot of that. We'll do some labs. We're going to see this in action, see how the ASA traffic and everything works. Okay.
So guys, any question related to CCNP, you can ask now. And today and tomorrow, we have only one hour session. And from next weekend onward, we can extend till 2.5 hours every Saturday, Sunday. So Arun, one thing I just want to confirm. So we are starting with ASA and FTD, correct?
Right.
Okay. And after ASA, FTD, what modules we are going to cover?
After ASA and FTD, we'll go over VPN.
Okay.
After VPN, we'll do ICE.
Mm-hmm.
And then after that, we'll do content security, infrastructure security. So just like we have listed in the brochure.
Yeah. So guys, this entire program is more than 100 hours of live training. Even I can say it's around 120, 130 hours. So whatever the content is there in CCNP security, we are gonna cover each and everything. Okay. So thanks for today, guys, and let's continue from tomorrow again for 1 hour, and from next weekend it's 2.5 hours every Saturday, Sunday. Thanks, Arun.
Thank you, guys.
Yep.
Thank you, Arun.
Thank you, Arun.
Thank you.